Okay, today we're going to discuss how elements on the periodic table are arranged. The first thing to look at or concentrate on is location, location, location. All right, where an atom's chemical symbol is on the periodic table can tell you a lot about it. Well, and let's look into what that is. All right, first things first. Where it is on the periodic table will tell you the number of box it is in. If you remember, we can number the boxes starting in the top left corner, starting at 1, and going to, on this particular table, 110. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that number, if you remember, is called the atomic number. Okay? And the atomic number tells you the number of protons in an element or an atom of an element. And since all of these atoms on this periodic table are in their neutral state, their neutral electrical state, that means the number of protons is equal to the number of electrons. Okay? In addition to the atomic number, you can also figure out which column each element is in. And what that tells you is that it's very similar to the other elements in that column. So in group 1, you have what we call the alkali metals. And all of these alkali metals, okay, are very similar with regards to their traits and the types of other elements that they react with. And then you have the alkaline earth metals. And they're very similar to each other. So lithium is much more similar to sodium than it would be beryllium. And lithium is more similar and more alike potassium than it would be beryllium or magnesium or calcium. So lithium is more similar to all the elements in its column or family, all right, than it is to elements in another column or family. So if you ever asked a question like, hey, what is more similar, lithium, rubidium, or beryllium, which is lithium more similar to, beryllium or rubidium, you would say rubidium because they're in the same family and they therefore have similar chemical structures with one electron in the outermost shell. So they react with very similar elements. Okay? And they share very similar chemical traits. So we're going to go over here 13, 14, 15, 16, and 17, and 18. Okay? Now, the periodic table is separated into 3 major parts. Okay, I'm just going to clear this off for a second. On the left-hand side of the staircase, and by staircase I mean this area right here. Okay. See, it almost looks like a staircase. All right, you have 7 what we call metalloids. Okay? Well, some people will dispute that in the number, but we're not going to concentrate too much on which metals are metalloids, but we'll just call these 7 metalloids for our intents and purposes this year. Okay? So you have boron, silicon, or silicone, however you want to say it, germanium, arsenic, antimony, tellurium, and polonium. And those are the 7 metalloids we're going to discuss. And this is kind of like the middle ground of our periodic table. So the metalloids are right here. And to the right of the metalloids, you have the nonmetals. And to the left of the metalloids, you have the metals, with the lone exception being hydrogen. Hydrogen is a non-metal, but it has very similar structure to the metals in the alkali earth metal group. So that's why it's put over there with the alkali metals, excuse me, not alkali earth metals. Okay? Now, all of these elements to the left of the staircase are metals, and metals share very similar traits. Okay? Metals are good conductors of heat and electricity. So metals are used in pots and pans So when you heat them up, they transfer the heat to your food. Or they're also very malleable, which means they can be hammered into sheets. And the way I remember that is another name for a type of a hammer is called a mallet. And you can hammer them into sheets so you could create things like cars or, like I said, pots and pans. Okay? They're also ductile, which means they can be pulled into wire. Okay? So you'll see metals used in wiring. And remember, because they're good conductors of heat and electricity. All right, we'll do this. Put heat. Sorry about the writing here. And electricity. Because they're good conductors of heat and electricity, they can be used in wiring for homes and things like that. Okay? Metals they have what we call luster, which means they're shiny. Okay? And they have high melting points, which is very useful in pots and pans. Otherwise, you'd be heating up your pot and it would melt all over your stove and you wouldn't be able to heat anything up in it. So they have high melting points. And when we talk about ionic bonding, metals lose electrons and form positive ions. Okay? Okay? Now, nonmetals are poor conductors. Okay, of heat and electricity. Electric, okay? Therefore they are very good insulators. Okay? So the insulation, so what you'll find is wires a lot of time wrapped in materials that are made up of nonmetals. Because they don't conduct the heat, you can then grab them. So like you'll see your pot on the stove have a different substance wrapped around the handle so that when you pick it up, you don't burn your hand. Otherwise, the heat can transfer all the way through that metal and heat up the handle as well. Okay? They are brittle, which is the opposite of malleable. All right? Brittle means if you hit it, it will shatter. It cannot be bent and hammered into sheets like pans or cars or whatever. Okay? They are not ductile, meaning they cannot be pulled into wire. They are dull in appearance, which means they lack luster. They don't have luster. They're not shiny. Okay, and like I said, they're very good insulators. Okay, so when you have products that hold heat in your house, that's called insulation, and that insulation is made up of non-metal type material so that the heat doesn't transfer to the outside of your home. Or through a wire, you'll see wire wrapped in materials. It used to be wrapped in like paper and things like that. And now it's wrapped in rubber coatings and stuff like that don't transfer the heat. Okay? Now, nonmetals like to gain electrons. Okay? And that causes them to form negative ions. All right? Now, metalloids are right in the middle. So guess what? These metalloids, they have traits of both metals and nonmetals, depending on which metalloid you're talking about. All right, so metalloids have traits of both. All right, metalloids are better conductors of heat and electricity than nonmetals, but not as good as metals. All right, so we call them in-betweeners. Okay. All right, so they're better conductors than nonmetals, but not as good as metals. All right? Now, they are malleable and they are ductile. So they share traits. They are malleable. They're ductile. Okay? Some have luster. All right? So some have luster and some are dull. Okay? They are solids at room temperature. All right? You have to realize most metals are solid at room temperature as well. Okay? Metalloids are solid at room temperature as well. Now, some metalloids are, because of these traits, they can kind of manipulate the electricity that goes through them, and you'll find that metalloids are a lot of times used in computer chips and things like that. You might have heard of something called Silicon Valley. All right. Well, Silicon Valley was founded because they used silicon in the production of computer parts. All right, and silicon is a metalloid. Okay, so that's basically how this periodic table is set up. You have on the left-hand side, you have all the metals. So you have all the metals over here, okay, and all the nonmetals over here, okay, and then in the middle you have those in-betweeners called the metalloids. All right, so you should be familiar with the different traits of metals and nonmetals, and therefore metalloids are kind of in between. So make yourself familiar with it. You can find a detailed explanation right here, or you can look in your notebook on page 19 in your notebook. Okay, that may change from one time to the other, but it is in your notebook. Okay, and we're just going to go back and remind ourselves of some things, that elements exist as metals, metalloids, and nonmetals. All right, most of the elements on the periodic table are metals. Okay, and most of them are in the solid state. There are some nonmetals, all right, and some of them are gases and some of them are solids as well. Okay, there's only a couple liquids on the periodic table. Okay, mercury being one of them, and that's a liquid metal at room temperature. Okay, bromine being another one, and that's a liquid nonmetal at room temperature. All right, these metals, metalloids, and nonmetals are either solids, liquids, or gases at room temperature, like we just said. The metals are located on the left-hand side, the nonmetals on the right, and the metalloids are in between them that form that staircase. We said there's about 7 of them that we're going to concentrate on. Okay, there is some dispute. Some people say there's 8 or 9 or whatever, or only 6, but we're going to just stick with the 7 for our intents and purposes this year. Okay. Now, what else can we learn from the periodic table? Let's go back. Well, the group number, if you remember, group 1, 2, 3 through 12, 13, 14, 15, 16, 17, and 18. The group number can tell us how many valence level electrons they have. All right, group 1 has 1 valence electron. All the elements in group 1 have 1 valence electron, and those are known as the alkali metals. In group 2, you have all the elements have 2 valence electrons, and they're known as the alkaline earth metals. Okay, we're not really going to get too much into the what we call the transition metals down here. All right, but then we get to the boron group, and you'll see that the boron group has metalloid in it, right? Because if you remember, we have our staircase here. Right. So our staircase of our 6 metalloids. Okay, so the boron group has a metalloid in it and then 4 metals. All right, and you know that all of those elements have 3 valence electrons. And the carbon group has 1 nonmetal, 2 metalloids, and 2 metals in it. And they have 4 valence electrons. Right? Now, the nitrogen group, 5 valence electrons, oxygen group, 6 valence electrons, and now we have the halogens, which have 7 valence electrons, and the noble gases. Now, when we talk about reactivity on the periodic table, the alkali metals and alkaline earth metals are the most reactive metals. The alkali metals being the most reactive metals, alkaline earth metals being the second most reactive metals. The halogens are the most reactive nonmetals, and the oxygen group is the second most reactive nonmetals. Okay, so the alkali metals are the most reactive metals. Now, these metals metals tend to give up electrons. So electrons go from metals to nonmetals. And therefore, the metals form positive ions, and nonmetals form negative ions. Okay? Now, the group number can also indicate that they are in the same family. So therefore, they are much similar to one another than they are to any element in another group or family. So elements of the same column or row are very similar to one another because they're in the same family or group. So if they ask you, like, what's chlorine is more similar to which element, and they gave you fluorine, silicon, oxygen, or argon, you would select fluorine because fluorine's in the same family and they have the same number of valence electrons. So therefore, they react very similarly with regard to other elements and chemicals. Okay? So basically, some of this is a review. The main point is, look, there's three types of elements on this periodic table: metals, metalloids, and nonmetals. Metals have very distinct characteristics that are very distinct compared to nonmetals. Nonmetals have very distinct characteristics to themselves, so they're almost like at opposite ends of the spectrum. And then in the middle, you have metalloids, which kind of share the traits of both metals and nonmetals. Okay? And that's it for today.